Okay, carboxylic acids are the first one. They have what we call a carboxyl group, and we've seen this before. COOH as the extension. They can still be saturated because the double bond isn't between carbon-carbon atoms. The double bond goes to the oxygen. So they're weak acids, and this is what a carboxyl group looks like. So here's your carbon. It's going to be double bonded to an O, and then it's going to have a hydroxyl group off of it. Okay? So COOH. This is what it's saying, where the double bond here isn't between carbon-carbon atoms. This is the double bond here. COOH. Okay? They're weak acids, which means that they donate the hydrogen. Remember, all the way back to Chem 20? Water. Okay? In this part here, we have the weak acid. This is acting as our base. So the acid is the proton donor, and the base is the proton acceptor. Because it's a weak base, we're going to see this equation go backwards and forwards. And this is where the hydrogen comes off of your hydroxyl group. And you create, what do we call that guy? You remember? H3O plus. What do we call that guy? The hydronium ion.
Okay, fine. I was
Okay.
gonna steal my thunder.
Oh, you got water things too.
Hydronium ion. Okay? So this becomes our, and we're going to get to this in about 3 units, what we call our conjugate base, and this is our conjugate acid. Okay, that's introducing new terminology for you. Okay? So these become a little bit more complicated. So you have to identify and name the longest carbon chain that includes the carboxyl group. So this COOH has to be a part of the longest carbon chain. Okay, so now we have a new chunk. This is the ultimate on this one.
So this is top of the hierarchy now?
Top of the hierarchy now, okay? And you always start numbering at this carbon that's double bonded to an oxygen and to a hydroxyl group. Okay? You drop the E at the end of an alkane group, and you put it with an OIC. So if you had alkane, this one here, you change it to whatever kind of alkane it was, and you put OIC instead. So if we had pentane, we're going to change it to pentanoic.
Wow, that doesn't mess with everything that I've ever
Okay.
done in my life.
So the E just gets replaced with OIC. Pentane becomes pentanoic acid. And then you look after any side groups attached to the main carbon and you number it and name it the same way as before. Okay, so if we looked at something like this, okay, so our main chain has to include the carboxylic group. We see this double bonded O and an OH, so we know we're dealing with a carboxylic acid. So 1, 2, 3, 4, 5. It's 5 carbons long. We start numbering at the carboxylic acid. So 1, 2, 3, 4, 5. And then we identify any side chains that we have. And we see that there's one here. And what kind of side chain is that? Methyl group. There you go. So 3-methyl. pentanoic acid. And again, we don't put the 1 in there because the 1 has to start at the carboxylic acid.
What if it's in like the middle or that doesn't happen?
We call it something different. It's got to be on the end. You wouldn't have an alcohol group. You have to have a double bonded O and an alcohol group.
Oh, so it like have to be.
So if it was in the middle, you would have your double bonded O, but you wouldn't have your alcohol group, so it would be an ester, which is where we're going. Okay?
Oh, yeah, that's awesome.
I don't want to move my smart.
Are we going like all the way to esters today?
I think we should be able to.
Will my brain be able to? Yeah, I'm really tired today. I can't guarantee you remember. Actually, the stuff isn't
That
that
complicated.
bad.
In the moment, it's not that bad.
You just start talking and then I'm like, well, I tried. And then
This one's going to get complicated right away.
I would just say no way.
Yeah, the Noah gas. That's how I would say it.
Aromatic.
Why is everything so funny today?
I'm not writing in the hydrogens simply for the fact I can't reach it. I have the board up too high. I'm being totally lazy. Okay, so we need to recognize that we see a double bonded O and an alcohol off of the same hydrocarbon. That's very key. If you just have a double bonded O or you just have an alcohol group, you don't have a carboxylic acid. Okay, you either have an alcohol or you have the beginnings of an ester. Longest chain has to include this one here. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. 2, 3, 4, 5, 6. So it doesn't matter. 1, 2, 3, 4, 5, 6. And then we need to identify our side chains. So we see that there's one here. There's one here. And there's one here. And here's our carboxylic acid group. So what kind of side chains do we have?
An ethyl and 2 methyl?
Okay, so this is your ethyl. This is a methyl. And this is a methyl. Okay, this is our carboxyl group. So we have 6 carbons. So that's going to be what? What do we call 6 hydrocarbon? 6 carbons? Hex. Replace the E with an oic. So we know we're dealing with a hexanoic acid. And we label accordingly. On 2, we have an ethyl. And on 4, 5, we have a dimethyl. 2 ethyl, 4, 5 dimethyl hexanoic acid.
Oh, yeah.
Okay?
Hold on, I just have to
So now we have this kind of question. It says draw and name 2 different carboxylic acids that have the molecular formula of C4H6H8O2. So we get to come up with the picture. This means that the first carbon has to look like this. So there's 1 carbon. Now you have 3 more carbons to deal with, however you feel like. And you need to make sure you only have 8 hydrogens. Here's 1. And you only have 2 oxygens. Here's 1, 2. So now you're left with 7 hydrogens and 3 more carbons to draw.
Can we throw another one?
Can we what?
Do we have double bonds or no?
Yeah, you can. There's no, you can't.
Oh, there's 8.